Hello, my name is Martin Kolarik, and let me welcome you to our presentation regarding the paper on the implementation of Planar 3D transfer learning for end-to-end Unimodal MRI unbalanced data segmentation. It is an accompanying paper to our main paper at the ICPR conference, and let me start with saying something about the ideas in our main paper. So, it is basically about transformation operation of 2D neural network weights into Planar 3D and using them as a transfer learning source for autoencoder neural nets that were used for segmentation of multiple sclerosis lesion in the raw MRI imaging. Some motivation. How is transfer learning done usually in semantic segmentation? So, this is a photo of a dog, right? And we train a classification network to classify 2D images, usually an ImageNet dataset. And after it's trained, we can use those weights as an encoder part in an unencoder segmentation network, and this approach works really well. But those are 2D images, right? What can be done for 3D convnets? So that's where our work comes in. We basically transformed the 2D weights, the 2D convolutional net cores, as can be seen here, into the Planar 3D counterparts, according to this equation here. This enables us to use the already trained networks as a transfer learning source for 3D autoencoder neural nets. So we use this network that is depicted here. It is based on 3D unit with implemented residual skip connections. It has a planar 3D VGG encoder and a standard 3D decoder that was randomly initialized and trained. The data that we used was an MSSEC 2016 dataset, which was 15 MRI head scans. It was heavily unbalanced. This lesion voxel ratio in 0.2%. And here you can see some example. Input to our net, and this is the output of our net. If you look at the reference that is here, you can see that we got a pretty good result. So, in the accompanying short paper, we included details on the implementation of our work, hyperparameter settings during training, some dataset processing, and cross-validation data selection. We published our source code, and it was verified to be reproducible by the reproducibility library reviewer. So, let me conclude that we did present our accompanying short paper at the RRPR, and we published complete source code under the open source license. Thank you for your attention. Our main paper oral presentation is on the Thursday at 4 p.m. in the track T.16. You're welcome to join. Thank you.